Well, hello, calculus students and seekers of truth. In this lesson, we will learn about improper integrals. Now, an improper integral kind of falls into two different categories. Either it has a positive infinity or negative infinity as one of the limits of integration, or the function that you're integrating over actually has some discontinuities. So before we get to the details and all of the algebraic work, let's see an example visually. So if you have a function whose graph looks something like this, and it has a horizontal asymptote, and say we want to know the area of this function from 1 all the way to infinity. So let's call this function f of x, and we want to know the area of that from 1 to positive infinity of f of x dx. So that is one possibility. Or another possibility would be that if you have a graph and say there is a non-removable discontinuity, and say it has an asymptote that looks like this, a vertical asymptote this time, okay, that looks like this. And we want to know the definite integral this time from a to b of this function. Well, let's call this one g of x dx. Now, this vertical asymptote complicates things because you have this area here, but this area suddenly spikes up to infinity, and on the other side as well. So in both cases, the first one up here and the second case, these are considered improper integrals. Now the second case, it's a little bit trickier than the first case because it's not obvious that it's going to be a improper integral unless you know something about the function. Now at this point you might be tempted to say, well, all of these integrals, they're going to have infinite area, but that's not actually true. Oddly and surprisingly and wonderfully enough, there are many cases where an integral or an area that is infinitely wide actually has a finite area, or at least it has a finite maximum limit, okay, to that area. And there are actually many applications in engineering, and particularly in probability and statistics, where we have to grapple with areas that have no boundary and yet may still have a finite measurement. All right, so that's a very, very brief introduction to improper integrals. Watch the next videos and we get to all of these specific details. Thank you for watching and have a wonderful day.